In this video, we're going to learn how to solve for a in vertex form of a quadratic when a is not equal to 1. So the vertex form of a quadratic is y equals a times the quantity x minus h all squared plus k. Notice that our vertex is hk. I also want you to notice that sometimes you can see the vertex form written as f at x, and you just have to remember that y and f at x mean exactly the same thing. So you can substitute f at x for y just because it makes it easier to see. So we also need to remember what the parent function of the quadratic looks like. And I specifically have the points here for you to see the spacing. So notice that the vertical spacing between the points is vertically up 1, then vertically up 3, then vertically up 5 for every one space to the right. A vertical spacing like this means that our value of a is 1. Another way of looking at it is if there's no number written in front of that parentheses of x minus h all squared, that means our value of a is 1. However, when you're looking at a graph, notice that in this case, the spacing between my first point to the right is more than 1 from the vertex. That means that this does not have a value of 1 for a. This means this function has been stretched. So that means we have to calculate what the value of a is. We can't just guess. Because we have a point, negative 1, 9, that we've been told is clearly on that function, we will have to also use that point to figure out what the value of a is.
A quadratic function has its vertex at the point -2, -4. The function also passes through the point 1, 9. We want to find the equation of the quadratic function in vertex form, also referred to as standard form. So we want to find the quadratic function in this form here, where we'll have f of x equals a times the quantity x minus h squared plus k, where the vertex will have coordinates h, k. But let's also replace f of x with y and use the equation y equals a times the quantity x minus h squared plus k. Now we're also told the vertex has coordinates -2, -4. And the function also passes through the point 1, 9. So to begin, because we're given the vertex, we know that h must be equal to -2 and k must be equal to -4. So for the first step, let's perform these two substitutions into our equation. So we'd have y equals a times the quantity x minus, h is -2, so I'll have minus -2. We'll simplify this in a minute, squared, and then plus k, where k is -4. Let's go ahead and simplify this. Minus -2 would be plus 2, so we have y equals a times the quantity x plus 2 squared, and then instead of writing plus -4, let's just write -4. Notice in this equation we have three unknowns. We have x, y, and a. But we also know the function passes through the point 1, 9, which means x equals 1 and y equals 9 must satisfy this equation. So now we'll substitute 1 for x, 9 for y, which will allow us to find the value of a, which will give us the equation of our function. So again, using the point 1, 9, we would have 9 equals a times the quantity x plus 2, which would be 1 plus 2, squared minus 4. So we'll have 9 equals, this is going to be 3 squared or 9. 9 times a is 9a minus 4. We'll go ahead and add 4 to both sides of the equation. That would give us 9a equals 13. Last step, divide both sides by 9. So we have a equals 13/9, which is the last thing we need to find the equation of our quadratic function. We'll just take this equation here and substitute 13/9 for a, and we'll also replace y with f of x. So our quadratic function would be f of x equals 13/9 times the quantity x plus 2 squared, and then minus 4. Let's go ahead and verify this by looking at the graph of our quadratic function. Here's our graph. Notice how the vertex does have coordinates -2, -4. And this parabola also passes through the point here with coordinates 1, 9, which verifies our quadratic function is correct. I hope you found this helpful.